Hey everybody, welcome back to The Hobby Musician. Now, for today's video, I'm both excited and a little bit nervous because if you're a longtime viewer, you might already know we just received our very first at-home CNC / laser cutting machine, all with the goal of hoping to elevate the level of detail and precision that we can put into our guitar builds here on the channel. Now, don't worry if you haven't seen those videos or if you want an easy place to get caught up on all of the videos in this journey. I'm going to go ahead and put a link to a playlist in the corner right now. So after this video, you can go back there and click in to see any of the steps in this process. Now, the other thing I want to take care of right at the top of the video is I'm going to go through some overview. I'm going to talk about the instrument that I have. But please understand, standard disclaimer, I'm not sponsored by any of these companies, but I also know that sometimes sifting through model numbers and specifications and accessories can be a little daunting. So if you hear anything that you want to investigate yourself in this video, including like the exact machine that I got, I'm going to go ahead and put some Amazon affiliate links down below the video, description section, comment section. So if you kind of like it and maybe want to consider getting into this yourself, head down, click into it. It'll take you to exactly what I'm talking about. All right, well, what are we going to do in this video? Well, as I was learning and doing my homework before I bought the machine, every single tutorial you'll ever find says this: if you're new to CNC, there are 3 things you need to do first. You need to test it, then you need to test it, then you need to test it again. And that is what I'm going to work towards in this video. I want to start by giving you an overview of what the process looks like. And then we're going to end, and I'm going to take you through all the tests that I did and show you what I was able to start getting used to before embarking on the really good timbre and the full instrument builds. Okay, so for any CNC beginner out there, there are 3 distinct phases that you're going to have to go through when it comes to doing a project. The first phase is going to be the creation of the digital model. Now, if you think about it, CNC is all about taking a block of material, whatever that material might be, and carving out an object. Well, we can't carve out an object if we first haven't created that object in the digital space. Now, there are tons and tons of platforms out there where you can start generating 3D models and all of that kind of stuff. Some are free to access, some are paid subscriptions. And it just so happens that my role as a teacher at the school that I work for, we have an educational license, an educational subscription to OnShape. So sure, that's the one that I'm going to use, but I'm not going to go through all the pros and cons of every single piece of software. But I found for me, going into OnShape as a complete beginner wasn't that bad. After just 1 or 2 quick videos, I started to get the hang of what the tools did and how the whole space was set up. It was fairly intuitive. So if you do have access, I do recommend that one. But as I said before, lots of other ones would work. Well, what is it that you're going to do? As I mentioned before, we want to build guitars. We want to build instruments here. So I needed to first set out and create 3D models of all of the pieces that I was going to need. I needed to be able to have very carefully controlled curves on the body, place the pickup cavities exactly where I needed it, the neck pocket exactly where I needed it. Now, among the other parts, one of the things I ended up being most excited about was the fingerboard, because when I'm using digital tools, I am able to set the exact distance between all of the slots for where the frets go so that I can guarantee myself at the end of this, the scale length, the fret placements, they're going to be perfect so that the instrument's going to play in tune up and down the neck. Now, if you get to the end and you get really good 3D models, there's a problem. I cannot just directly take those models and feed them to the CNC machine and let it go. CNC machines really are so basic that they only follow directions, like raise the head, move it over here, lower the head, move to the left, move to the right, go in a curve. They don't understand 3D shapes. So there has to be a second phase. You have to translate that. You have to have a computer program that will see the shape you're trying to make and then translate that shape into a series of hundreds and hundreds, thousands and thousands of individual commands. Move this way, move this way, move this way, then move down, then move this way, then move this way. And it's those commands that you can send to the CNC machine. Now, once again, OnShape has an add-on module that you can do this. Kiri Moto is one of the third-party plugins that you can add to OnShape, where it will load the model that you just created in the main workspace, and then you can start select. You can say, I want to flatten off the top, or I want to just carve out the main cavities, and you can make step after step after step, and it will create the commands or the G-code for that. It then saves a file, a G-code file, that you are now able to load into the CNC machine. So phase 1 is done. We've got our 3 models, or 3D models. Phase 2 is done. We've translated the 3D models into line-by-line codes. Now it's time for phase 3. We need to have some sort of control interface that we can use to run the CNC machine. Now, once again, there are so many out there, and depending on the model that you have, you might have special software that came with it. I personally use a freely accessible UGS, so Universal G-Code Sender, as the interface. It's generic enough that it can work with kind of any model. And what I do is I plug in the USB connector to the CNC machine, and I load that file of the thousands and thousands of commands, and it shows me a little preview of what those commands will look like. And if you can see here, every single little thin blue line is a movement of the cutting head that it thinks it's going to do. So you're able to sort of see and assess the situation even before you start. Now, this is also a good time to start planning out or testing out the speeds and the feeds that you're going to need. That's a term that I quickly became familiar with in researching this, but all that means is you're going to need to figure out, depending on your material, depending on the type of bit or cutting bit that you have on there, sometimes you need to be careful. You can't go too fast or you can't go too slow, depending on what you're cutting. So part of the testing phase is not just getting your models, getting your G-code and loading it. Part of your testing phase is get some scraps and just see if it goes too fast and it binds up, or if it goes too slow and maybe starts scorching the material. There's so much of that fine tuning, but once you get it, the beauty of digital files is you save all those settings, and the next time you're trying to make that same part, you load it up and you're ready to go. All right, well, what did my actual test turn out looking like? Well, to start with, I had some 3/4 inch MDF board just laying around from a previous project. So I decided, what if I just try to make a skinny version of a full instrument just to kind of dip my toes in the water and get my settings right? So the first thing I'm going to show you is the body that I ended up cutting out, and I'm going to show you the back of it first. Now, in addition to seeing kind of the nice parts of it, I want to first draw your attention to the weird channels. There's a weird curve up here, holes in different places. And this is a good example of what we covered in the very beginning of this video. Test, test, test. And I think I even said, if you think you're right, you're probably wrong. It happened to me. I did everything I could to set things the way I thought they should be set. I looked up forums, I took advice from people. And just for my machine, the settings weren't quite right. In fact, I had things set way too fast and way too aggressive. What ended up happening was the cutting head would try to follow one of the curves, one of those blue lines, but because I had told it, set it to go so fast, it ended up bogging down. And the computer, and in its kind of directions, it would think that it was going faster than it physically was. Then it would get to a curve and it would say, take the curve. But the cutting head actually wasn't where it needed to be, so it would take the curve. And that's where you get these weird things. This curve right here is supposed to be the same shape as the horn up here. And it just was going way too fast. So I did a lot of adjustments And then once I got the settings right, I just kept the same scrap piece in there, and I moved it around a little bit. But then once I slowed things down and I got the depths to be appropriate, you can see here, it was very easy at that point to have it cut in all of these test places. I got my electronics cavity with the little set-in lip and places for my magnets to go when I inset those into the cover. And then flipping it over, I took the same piece, flipped it over and lined it back up. And now with the settings, this is a lot cleaner looking because this was cut after I had fixed all those settings. I got my pickup cavities, all of the places for the control pot, and the neck pocket. Now I'm going to show you the neck that I made. So I got those settings and I thought, what if I make a neck? And like I said, the test is going to be whether or not these pieces fit together as well as the 3D models do. So the neck cutout, again, it looks really clean because this was done after I had got my settings. You can see here, I even had it go down and cut, level off the surface of that recessed headstock, cut in the channels. Then on the back, this is kind of the other benefit that I want to talk about. You can see the curves on this. Carving necks by hand has been one thing that I've struggled with ever since we started building instruments. But because you can use digital tools, you can kind of program any neck profile you would want and have the machine cut it out for you. So I did a little test curve on the edge of this, and with the cutting head, it went back and forth and got that curve for me. Now, I am going to say, no matter what you do, no matter how perfect your settings are, there's going to be some finish sanding. So I did have to come back with some sandpaper, a file, and kind of get some of the grooves out. But the basic shape was there, and it was really easy to do that. Now, the moment of truth is this. Does the CNC have the precision and the detail to cut a perfect fit? And as I get this for you on camera here, spoiler alert, the answer is yes. Once I was done with this, I was able to see this does allow me to quickly kind of crank out highly detailed, highly precise parts. And you can see here on the back, it fits perfectly. It's perfectly in line. The center line goes all the way through the instrument. So this may be the world's skinniest bass guitar, but this was the testing phase that I needed to be able to start dipping my toes to make the mistakes that I was going to make on scrap wood and to be able to see what this could actually do for future projects. So what that allows me to do now, after this video, I am going to now go and scale up. I'm going to go back to full-size models. I'm going to get some bigger blanks, longer blanks for the neck and everything like that. And I'm going to attempt to make my very first full-size instrument with this new CNC machine. Now here at the end, as always, I hope you got something out of this video. I want to thank you for watching, and until next time, play on, my friends, play on.